Hi, I'm Lorena Barthelmes, and my doctoral research revolved around the topic of occupant behavior and its impact on building energy use and thermal comfort. The common goal of our building energy research community is to reduce the impact of the building sector on global energy use, but to do so we really need to look behind the facades. There, we can find the real energy consumers, the occupants, interacting with building controls to meet their comfort requirements. This shows that it is essential to understand the dynamics behind the human-building interaction. In this context, I identified 5 research gaps. The first is a lack of understanding to which extent occupant behavior can impact energy use, especially in high-performing buildings. I implemented different occupant behavior lifestyles in Energy Plus and identified key behavioral patterns in high and low-performing buildings that mostly influence energy use. The analysis showed that occupant behavior has an even bigger impact in high-performing buildings and that the nearly zero energy target can only be reached with aware users. The second gap relies between real and predicted building energy use due to an oversimplification of the human factor in simulation programs. As an innovative approach to model the stochastic nature of human building interactions, I explored the Bayesian network framework, which turned out to be a powerful tool to capture probabilistic relationships between window control behavior and driver factors. To find the best model, I explored and compared different model configurations and tested different machine learning techniques. A further gap is the absence of qualitative data and individual characteristics of occupants in existing models. For this reason, I developed a tailored survey framework and integrated qualitative data such as individual thermal comfort attitudes and preferences in the Bayesian network model. The model, based on survey responses and field measurements in Danish households, showed that the newly introduced factors have a significant impact and that they should be carefully taken into account. Another gap is the lack of reliable and affordable ways to collect and model large-scale occupant behavior data. Therefore, I modeled national Danish time use survey data in which over 9,000 individuals reported their daily activities. I profiled large-scale occupancy data as well as other energy-related activities and analyzed their time durations during different days and seasons. The large-scale occupancy profiles were made freely available online and can be directly downloaded and implemented in building simulation programs. The last gap is the lack of innovative solutions for motivating and assessing behavioral change towards energy efficiency goals by combining technological and behavioral change measures. In this context, I had the chance to contribute to the development of several energy engagement campaigns, such as the European Horizon 2020 Mobistyle project, in which combined feedback on energy, indoor environment and health is provided through innovative ICT solutions to leverage more aware behavior. To conclude, I would like to highlight that this dissertation was aimed at contributing to bridge 5 key research gaps in energy-related behavioral research. It is certain that, given the complexity of the human perception and mind, further work is needed to explore a more extensive set of drivers to enhance impact estimation, modeling, qualitative investigations, large-scale profiling, and raise of user awareness. Thanks for listening.